Good day, guys. Welcome to my YouTube channel. We're going to look at the question 7, which is acids and base questions in the grade 12 paper. Let's tackle the exam question paper. This is 2021, November 2021, question 7. Let's cut the chase. Now we have sulfuric acid. We have a sulfuric acid ionizes in 2 steps. We know what is ionization. It's when we dissolve an acid in water. Let's look at the first step. Here. We have the sulfuric acid in water and it produces the ions there. And we're given the Ka, the ionization constant of an acid, the equilibrium constant of an acid. And then we're given the second ionization, it's that conjugate base of an acid. It's dissolved again in water and it produces those ions. And we're given the equilibrium constant of an acid. Right? One thing that you need to note, once the Ka value is less than 1, that says it is a weak acid. Once your Ka value, the equilibrium constant for an acid, is greater than 1, that simply means that is a strong acid. So if we look at this K value, it's greater than 1, so it qualifies to be a strong acid. Even sulfuric acid is one of the strong acids. And the Ka value here, it has a lower Ka value, which is lesser than 1. It qualifies to be a weak acid. Now let's answer 7.1. It says define the acid in terms of Lowry-Bronsted. According to Lowry-Bronsted, the acid is a what? Is a proton donor. Now 7.1.2, it says write down the name or the formula of the substance that acts as an ampholyte in the above equation. What is an ampholyte? We need to understand what is an ampholyte. An ampholyte is some substance that have properties of being a base and an acid at the same time. So an ampholyte is a substance that acts as a base and also acts as an acid as well. So let's look at in the above equations. Here we have sulfuric acid. It donates proton to water. So water here in this case will act as a base. Here we have a hydrogen sulfate ion. It donates donates proton into water. So water here acts as a base. So water here doesn't qualify to be an ampholyte. Now let's look at the products. Here we have a hydrogen sulfate. Here in this case, this hydrogen sulfate acts as a what? A conjugate. Act as a conjugate base, because this hydronium ion can donate a proton there. Remember, this is a reversible reaction, so it will become water and that. So let's look at the hydrogen sulfate in this side. This hydrogen sulfate, it donates proton in water. How do we see that? We see the water becomes oxonium. So we conclude that this hydrogen sulfate here, in this side it acts as what? As an acid. In this side it acts as a base. So it is an ampholyte. So let's write it there. The formula is hydrogen sulfate ion, HSO4 minus. The name is hydrogen sulfate ion. Give reason for your answer. You can say in reaction 1, it acts, in this reaction, it acts as what? As a base. Then in reaction 2, it acts as an acid. Right, you got your 2 marks there. Now the second last question, it says the conductivity of the solution of hydrogen sulfate ion and sulfuric acid sulfuric are compared, so their conductivity are compared. Remember, when we talk about the conductivity, the stronger the acid, the more the conductivity. Check my other video. I do have the video on that, on the conductivity, reactivity. So the stronger the acid, the greater the conductivity. Remember, I said this one, it has a Ka value that is less than 1. That means it's a what? It's a weak acid. And this one, it has a Ka value that is greater than 1. That's a strong acid there. So the one with the lower conductivity is the second. So we say it's the second. And the reason for that, we'll say because of the Ka value is less than 1. And something, if it has a lesser Ka value, if it has a lesser Ka value, or you can say smaller Ka value, your answer, or you can say something with the smaller Ka value and it's a weaker acid, you can say it's incompletely ionized, incompletely ionized, right? Or you can say it has a lower concentration of ions. Right, let's move. Now 7.2, this question, it becomes interesting now. 7.2, it says calculate the pH, it says, let's read the statement first. It says the pH of hydrochloric acid is 1,02. So we're given the pH there. And the pH there. We know hydrochloric acid, it's one of the strongest acids. So its pH, it's supposed to be between 1 to 2. The strong acid, its pH is between 1 and 2. Or lesser than that. Right, now calculate the concentration of HCl. So what are we going to do? We are given the pH. So what are we going to get with the pH? From the pH, 7.2.1. From the pH, we can get the hydronium ion of an acid. So we change that pH. We say pH is equal to negative log H3O plus. So now, having this pH, it can gives us the hydronium ion by doing an antilog. So having that hydronium ion, you can do the concentration ratio to get the concentration of HCl. So we'll say concentration of hydronium ion is equal to the antilog. So that's how you do the antilog. When you have a pH, to want the hydronium, the concentration of hydronium ion. So it's going to be 10 to the power negative 1,02. So that it will be 0,0955 mole per dm3. Remember, that's the concentration. You mustn't forget the units. So when you ionize HCl into water, you have the hydronium ion plus Cl minus. So we'll do the mole ratio. This is the balanced equation. So we have this. This is the concentration that we just calculated. We have this and we want this. And this will do what we call, it's a concentration ratio. So we'll say HCl, concentration of HCl is to concentration of hydronium ion. The ratio between them is 1:1. So it's going to be 1:1. So we want the HCl. So we'll say HCl is equal to, when the ratio is 1:1, so the concentration is going to be the same, 0.955 mole per dm3. Now we have the concentration of hydrochloric acid by that. Now let's move to the next question, which is the 8-mark question. It's a difficult question and an interesting question. So in this question, you really need to understand this analogy or this example that I'm going to use here, right, in order to understand this question. Now, let's read the statement. It says, this HCl reacts with the sodium carbonate according to the following balance equation. So the HCl concentration that we calculated, now it reacts with the sodium carbonate, which is the metal carbonate. We know from our reaction, having the metal carbonate react with an acid, will have a salt and a carbon dioxide and water. Check my other videos of reactions. Now, how do they react? We are told 50 cubic centimeter of HCl is added. So this is a volume of an acid of it is added to a 25 cubic centimeter of sodium carbonate. This is a volume of a base, and we are given the concentration of the concentration of a base, and it is 0.075 concentration. This is a concentration of a base. Now the question now, it says these two are added. Okay, so this is a base. This base will be, we'll say this base is sodium carbonate. And if you look at the volumes here, we have 50 and we have what? 25. We have 50 and 25. So this is the what? This is the HCl. So the volume of this is what? It's 50 cubic centimeter. And the volume of this is what? It's 25 cubic centimeter, right? So we are adding these two into this one beaker. So when we are adding these two into this one beaker, certain portion from here will neutralize with the certain portion here. But looking at the amounts that we have, we can simply conclude which one will be an excess. Because of this amount of this is bigger than the amount of this, we can conclude that HCl is going to be an excess. But looking at the question as well, it says calculate the concentration of an excess hydrochloric acid in the new solution. So we wanted the concentration of the excess of hydrochloric acid in this new solution. This is a new solution. So we wanted the concentration of what will remain from the hydrochloric acid. So now let's say here, this purple color, it's when both acids neutralized. Let's say this purple color, it's when they're both neutralized, and the red color there, or the pink color, it's an excess, which is the excess of what? The excess of HCl. So what we want here, we want what? The concentration of that excess. Remember guys, as I've mentioned earlier, out of this there will be an amount that will react. Out of this, there will be an amount that will react. But here, this one will react completely with a portion of this. So we can conclude and say this sodium carbonate is a what? Is a limiting. It will be used up completely. So this one is an excess. It's not going to be used up completely. There's a portion of it that will remain. So we wanted the concentration of that portion that will remain. And everything from this hydrochloric acid was poured here, and this sodium carbonate was poured here. So that excess, it's in this solution. Remember, the total volume of this solution, it will be the V total. It will be 25 plus 50, that amounts to 75 cubic centimeter, right? Now, we want the concentration of that. Guys, This is very important. I'll do this in steps to calculate that. Step number 1, what do? You calculate the initial amounts. These initial amounts needs to be in number and needs to be what? In moles. So the initial, how do we calculate the initials? So I have the volume and I was given, let me write the concentration, and I was given the concentration. The concentration of this base, it was 0,075 mole per dm3. And here I was given the concentration as well. Concentration of an acid is the one that I calculated there. It's going to be 0.0955 mole per dm3. Right? So I'm converting these amounts that I'm given into number of moles. This one into number of mole. Right? So from the formula that says C is equal to N over V, because we have the concentration and the volume, we want the number of moles. So this is what I'm going to do. Substitute the concentration of sodium carbonate. This is the sodium carbonate. Let me write it here. Sodium carbonate. So the concentration of sodium carbonate is 0.075. And we want the number of moles. The volume there, it's 25. So when you divide 25 by 1000, it needs to be cubic decimeter. So it's going to be 0.025. And then when we cross multiply there, the answer will be the number of moles. The answer will be it's going to be 0.01875 mole. This is an amount available for sodium carbonate. Let's do it for 8Cl. 8Cl, the hydrochloric acid, C is equal to N over V. We substitute there the concentration. The concentration there, it's 0.0955. The number of moles, and we divide by the volume. The volume is 50. So 50, when we divide it by 1000, we convert it into cubic decimeter. It's going to be 0.05. We cross multiply. The answer there, the number of moles, it will be 0.0475 mole. Now, these are the number of moles available, or initial number of moles. So with these initial number of moles, what are we going to take? We're going to do step number 2. We're going to do what is the mole ratio. And what do I want by the mole ratio? I want the amount reacted of what? Of 8Cl. Remember, for 8Cl, we wanted the amount available. So when we wanted the amount remained, which is we want the excess. So having the initial amount, which is the amount available, we will need the amount reacted so that we can get the amount that remained, which is an excess. That's what we want. So what are we going to do? We will do the mole ratio. 8Cl is to sodium carbonate. The ratio between them from the balance equation is 2 is to 1. As 2 is to 1, so we wanted the 8Cl here, so we'll put an X there, and then the amount available from the sodium carbonate is that. So it's going to be 0.0018 1875, and then we cross multiply. So when we cross multiply there, the answer will be your X, it will be 0.0038 mole. So this is an amount of 8Cl reacted with the sodium carbonate. Now, step number 3, we will calculate what? An excess. Excess of what? Of HCl. How do we do that? We say the number of moles of an excess is equal to the number of moles initial minus the number of moles reacted. In order to get the amount that will remain, which is an excess, you need to subtract the reacted amount from the initial, right? So we'll say that the initial amount of HCl here, it was 0.0475. 0.0475 minus the reacted amount, it's 0.0038. So the answer here, it will be 0.00 that's 4095 mole. Guys, you can write it in scientific notation. It will be 95 times 10 to the power negative 4. That's the same answer. So this is the amount that remained. And this is an excess, but in number of moles. The question, it wanted it in concentration. So we'll say concentration of an excess is equal to the number of moles of an excess divided by the volume. Remember, remember this excess, I told you initially, it's in this volume, which is this volume. It's what? It's 75. When you add 50 and 25, it gives you 75. So this is the total volume. So when you wanted the concentration of this excess, you must use the total volume. So it will be total volume. So it will be this answer, 9.5 times 10 to the power negative 4 divided by the total volume. There is 0.075. That's 75 cubic centimeter, but we convert it into cubic decimeter. So the answer there, it will be 0.013 mole per dm3. That's the concentration. That's how. Guys, if you do not understand this question, please rewind and go back, rewind this video and watch it again, rewatch it up until you understand. Thank you.